Picture this. A female chimpanzee is giving birth. She is doing it largely alone, high in a tree, at night, with little more than the presence of other members of her group nearby. The labor is not effortless, but it proceeds with the mechanical directness of a system that has barely changed in millions of years. The infant emerges face first, in a position that lets the mother reach down, guide it out with her own hands, and bring it straight to her chest. From the first strong contraction to a living infant in her arms, the whole process is usually measured in hours. Within minutes, that infant is alert, clinging, and strong enough to grip its mother's fur. The mother herself is up and moving again almost immediately. This is what primate birth looks like when the engineering works the way it is supposed to. Now, picture something very different. An ancient woman, somewhere in Europe, 60,000 years ago. Her pelvis has been shaped by millions of years of walking upright, and that shaping has left her birth canal with a strange, twisted geometry. Narrow from front to back at the entrance, narrow from side to side at the exit, with a curved passage in between that forces her infant to rotate on the way out. Something no other primate has to do. Her baby's head, at the moment of birth, is already so large that it will pass through this canal with room to spare, measured in millimeters, not centimeters. Her labor will take hours at best, often many hours, sometimes days. And when the infant finally emerges, it will be facing away from her, the opposite of a chimpanzee birth, which means she cannot simply reach down and lift it out herself without risking bending its spine the wrong way. This is why, almost alone among primates, human birth has never really been a solitary event. It is why the ancient woman in labor is not alone in that hut or that shelter. She's surrounded by women who have done this before, who know what a normal labor sounds like and what a dangerous one sounds like, who know how to catch an infant as it emerges, how to manage the cord, how to recognize the moment when something has gone wrong. This is not tradition for its own sake. It is closer to a survival system. Human birth is constrained by such a narrow mechanical margin, so dependent on an infant's head rotating correctly through a curved passage at almost exactly the right angle, that the difference between a birth that goes well and one that kills mother and child can come down to inches and minutes. For most of our history, unassisted birth carried mortality rates high enough that assistance was never a preference. It was closer to a requirement for the group to keep existing at all. And that raises an uncomfortable question. This is a species that evolved without anesthesia, without surgery, without the ability to replace lost blood, and yet somehow carries the single most dangerous routine biological event of the female body strapped to the very center of its survival. So why did evolution never simply fix this? Millions of years of natural selection acted on a process where failure could kill both mother and infant in a single afternoon. Why did none of that pressure ever produce an easier birth? Isn't natural selection supposed to sand down exactly this kind of flaw? The answer turns out to be one of the more elegant and more sobering stories in evolutionary biology. It is a story about two selection pressures pulling in opposite directions for so long that neither one has ever been able to win, leaving the human body stuck in a permanent, uncomfortable compromise. Here is pressure number one. For millions of years, the hominin lineage has been rewarded, generation after generation, for bigger and more capable brains. The fossil record shows this plainly. Brain size in our lineage climbed steadily over deep time, tracking the cognitive advantages that larger brains delivered in social life, in tool use, in surviving a changing world. But a bigger brain needs a bigger skull to hold it. A bigger skull needs a bigger birth canal to pass through, and a bigger birth canal needs a wider pelvis to provide it, which is where pressure number two shows up. Because a wider pelvis is never free. Walking upright on two legs, the single adaptation that defines our entire lineage, demands a pelvis built to very specific proportions. The muscles that hold the pelvis steady while you balance on one leg mid-stride, the angle of the hip joints, the position of the thigh bones relative to your center of gravity, all of it depends on a pelvis shaped a certain way. Widen that pelvis enough to make birth easy, and you make walking measurably less efficient. Keep it narrow enough for efficient walking, and you get exactly the kind of birth canal an ancient woman had to navigate at real cost to her own survival. Evolution cannot have both. A pelvis built for effortless bipedal walking and a pelvis built for effortless birth are geometrically opposites. This is known as the obstetric dilemma, first proposed in the middle of the 20th century, and at its core, the logic still holds up. What later research has done is complicate the picture, adding layers the original two-pressure model never accounted for. One of those layers is metabolic, and it may matter just as much as the geometry. The human brain is the most expensive organ in the body per unit of tissue, burning through roughly 20% of an adult's daily calories, and an even larger share in a developing infant. That expense puts a ceiling on how long a pregnancy can continue That has nothing to do with the width of the pelvis. If a human fetus stayed in the womb as long as a chimpanzee fetus does relative to its own development, its brain would eventually demand more energy than the mother's body could realistically supply, while she still needed calories to survive herself. Somewhere around 38 to 40 weeks, that equation reaches its breaking point. Birth happens not only because the head has reached the limit of what the pelvis can pass, but because the mother's metabolism has reached its own separate limit at almost exactly the same time. The results of these two constraints acting together is something researchers call secondary altriciality, a clinical way of describing just how helpless a human newborn really is. A newborn chimpanzee arrives with a brain already at roughly 45% of its adult size, strong enough to cling to its mother's fur unassisted within hours. A human newborn arrives with a brain at only about 25% of its adult size, unable to hold up its own head, unable to regulate its own body temperature, unable to do anything at all without constant help. In developmental terms, every human infant is born early, not because something went wrong, but because staying in any longer was never an option the body could afford. That helplessness did not stay contained to the birth event. It reshaped everything that came after. An ancient woman who survived the danger of labor was immediately handed a second, longer problem. An infant that would need years of intensive care, far more than she alone could provide, while also recovering from birth and feeding herself. The same social infrastructure that gathered around childbirth had to extend into the months and years that followed. And some researchers argue this created a feedback loop that made the whole situation more entrenched rather than less. Groups that figured out how to support mothers and infants through both the dangerous birth and the long helpless infancy raised more large-brained children to adulthood than groups that did not. Those children grew up, had their own large-brained helpless infants, and needed the exact same support all over again. The social safety net around birth was not just a response to the problem. It may be part of the reason the problem was ever allowed to keep growing in the first place, generation after generation, without wiping the lineage out. Before we go any further, if you want to go deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans, 10 modules, over 3 hours of content, covering everything we never really talk about on this channel. What they feared, how they communicated, what hunted them, and much more. Plus, an exclusive PDF guide included. The link is in the description. Now, back to the birth canal, because the mechanics get even stranger. The idea that human birth is simply a case of a large head meeting a narrow pelvis under cells. Just how intricate the process actually is. A human infant's head has to execute a specific sequence of turns on the way out that no other primate birth requires. At the pelvic inlet, the head enters sideways, its widest point lined up with the widest point of the opening, which runs left to right at the top of the pelvis. Partway down, the head has to rotate about 90 degrees, so that, by the time it reaches the outlet, it is lined up front to back instead, because that is where the outlet is actually widest. Nobody is steering this. The mother cannot control it and cannot assist it. It happens because of the shape of the canal itself and the resistance the head meets as it descends. And it has to happen correctly, or the head simply gets stuck. When that rotation fails or happens only part way, the result is obstructed labor. Historically, one of the leading causes of maternal death anywhere a cesarean was not available, and one that killed a significant number of ancient women who had no such option. That same rotation is also the reason the infant is born facing away from its mother rather than toward her. Its face points toward her back as it exits, which means she cannot safely reach down and pull it free herself without risking a dangerous backward bend in its tiny spine. This single mechanical detail is likely the reason human birth, in every culture ever studied, has involved someone else in the room. It is not a tradition layered on top of a process that could technically work alone. The need for help is built directly into the geometry. Some ancient women did give birth without attendants and survived, when the rotation happened cleanly, when nothing went wrong, when the cord in the afterbirth came without complication. But when the rotation stalled, when the infant was positioned badly, when labor dragged on too long, or when heavy bleeding followed delivery, the women without an experienced attendant nearby fared far worse than the women who had one. That difference in outcome is exactly the kind of pressure that shapes a species over time, and it shaped ours toward cooperation at the moment of birth rather than solitude. The ancient birth attendant. The older woman who had witnessed dozens of births before, who could tell the difference between labor that was simply slow and labor that was actually failing, who knew how to reposition an infant caught in an awkward angle, who recognized the signs of dangerous bleeding and knew what to do about it, was one of the most quietly important people in any ancient community. None of that knowledge was written anywhere. It existed only in the minds of the women who had lived it, passed down through direct apprenticeship to the next generation. Losing that knowledge, through death, through a group being separated, through any of the disasters that could scatter a small ancient community, was never just a social loss. It was a direct threat to whether that group's children would survive being born at all. So why didn't the pelvis simply widen and solve the whole problem? Because a wider pelvis has its own hidden cost, paid every single day, not just on the day of birth. A wider pelvis forces a greater side-to-side sway of the body's center of mass with every stride, and that sway costs real energy. In a world where every calorie had to be earned through sustained physical effort, that extra cost mattered. It was its own selection pressure, pushing back against pelvic width just as hard as the birth canal was pushing for it. What we ended up with is not the widest possible pelvis and not the narrowest. It is the specific compromise point where these two opposing pressures settled, a solution that was good enough to keep the species reproducing across thousands of generations without ever being safe or comfortable or free of risk. Interestingly, more recent research has found that this compromise is not identical everywhere. Pelvic geometry varies more across human populations than the original obstetric dilemma model assumed, with some populations showing shapes more favorable to easier birth and others less so, tracking loosely with the different evolutionary pressures each population's ancestors faced. The compromise, in other words, was never locked to a single universal setting. It was tuned slightly differently wherever humans went. There is one more twist to this story, and it involves the cesarean section, the modern solution to exactly the mechanical failure ancient women could not survive. Women and infants who would once have died from a mismatch between head size and pelvic geometry now routinely survive that same mismatch, then go on to have children of their own, passing along the very traits that once would have ended with them. Researchers have pointed out, carefully and without any judgment attached, that this may be quietly loosening the selection pressure that kept human pelvic geometry from narrowing further. This is not a criticism of modern medicine, which has saved an enormous number of lives and will keep saving more. It is simply an observation that a technology invented in the last century or so may already be nudging an evolutionary equilibrium that took millions of years to settle into place, in ways we will not be able to measure for many generations yet. So, why did evolution never fix ancient childbirth? Because fixing it would have meant choosing a side, either shrink the brain and give up the cognitive advantages that built everything about how humans live, or widen the pelvis and give up the walking efficiency that built everything about how humans move. Both options cost too much in a different currency. The system settled instead into a permanent, uneasy compromise, one that kept the species alive across thousands of generations while leaving every individual woman to personally carry a level of risk that, on paper, looks like a design flaw in an organism that had every chance to fix it. Ancient women understood this not as evolutionary theory, but as lived experience. They understood it from attending births that went well and births that did not, from losing friends and sisters and daughters to childbirth, from carrying forward, generation after generation, the precise knowledge of exactly how narrow that margin really was. The rituals, the careful attendance, the accumulated knowledge that surrounded birth in every ancient culture were never decoration. They were the safety net that biology itself had failed to build. They built midwifery because evolution could never build a better pelvis. That knowledge, held by specific women and passed hand to hand to other specific women, refined across countless generations of direct experience with the single hardest mechanical problem the human body ever had to solve, was, in the most literal sense, the difference between this lineage continuing and this lineage ending. The compromise held. The species is here, and the women who made that possible did something, in practical terms, that evolution itself never managed to do.